And 12 days after launch, the James Webb Space Telescope is ready to deploy the biggest reflecting surface ever sent into orbit. 12 days after launch, the James Webb Space Telescope is ready for a critical stage in its mission, the unpacking of its giant primary mirror. It's the biggest reflecting surface ever sent into orbit, and it's hoped that this will detect the light from the very first stars to shine in the cosmos. Our space editor, Rebecca Morell, is following the mission.
Travelling through space and getting ready for its mission to begin, the James Webb Space Telescope successfully launched nearly 2 weeks ago. It's a successor to Hubble and will revolutionise our view of the universe.
Webb has the potential to blow people away, even people who are used to Hubble. And I know that's hard to imagine, but the instruments are so powerful. The telescope is so powerful. Almost anywhere we look, we're going to be breaking new ground in a huge way.
The telescope is so big, to get into space, it had to be folded up like origami. It's been busy unfurling. First, its sunshield, which is the size of a tennis court. But now a vital stage of the process is beginning.
The mirror is the most important part of the telescope. Its two folded sides open up and lock into place. At 6.5 metres wide, it's so big that it consists of 18 separate hexagonal segments. They're made from beryllium, a stiff and lightweight metal that can withstand the extreme temperatures of space. The whole thing is covered in gold, so thin that the entire coating weighs just 50 grams, the weight of a golf ball.
Although it's made of segments, each one has to line up perfectly for it to act as a single huge mirror.
So each one of those mirrors, which is very lightweight, they have motors on the back which can move them up and down, tip them sideways, rotate them, and even slightly bend them to make sure that they have exactly the right focus.
The telescope will be hunting for the most distant stars and galaxies. But to do this, it doesn't use visible light like the Hubble Space Telescope. It uses a kind of light we can't see, infrared light.
Our universe is expanding. And as the universe expands, everything in it expands as well, including light. When we talk about galaxies that are incredibly far away, the expansion of the universe has expanded the wavelengths of the light and moved the light into the red areas, the infrared.
This is an image of the pillars of creation taken by Hubble. It's a place where stars are born. But because James Webb uses infrared light, it will be able to see through this dust, showing us the multitude of stars that lie beyond. But all of this rests on getting the mirror fully opened and then aligned. Nothing this complex has been tried in space before. But if it works, by the summer, the first images should be sent back. And scientists say they'll be spectacular. Rebecca Morell, BBC News.